This is Peter Brown from Bio 108. Today we're going to talk about biomes, deserts, water, riparian areas. Here's a picture of me on the Salt River, and that's Red Mountain in the background. So biomes, or sometimes we call them life zones, are the biggest terrestrial divisions of the biosphere. So we're not going to look at the aquatic biomes, we're just going to look at the divisions on Earth. And so different biomes or different life zones have different plant and animal life, and we'll talk about why that is. There's a quick quiz on this video on terrestrial biomes, and you'll find it very easy. So the two climatic factors which determine the vegetation and what biome you're in are temperature and precipitation, which includes both rainfall and snowfall. So high precipitation, high temperatures, you're in a tropical rainforest. Low precipitation, very cold temperatures, you're in the Arctic tundra. Okay? But then you could go up here and say, well, what if you have warm temperatures but the rainfall goes down? Then instead of a tropical rainforest, you have a tropical seasonal forest or a savanna. Okay? What if you have lower rainfall still? Then you have a tropical desert. One of the great things about living in Arizona, what makes it so special, is that we have 6 different biomes within Arizona. That's not true of most states. Most states don't have the diversity of Arizona. So where Phoenix is in the southwestern part of the state is all the Sonoran Desert. So all this brown is desert. Okay. If you have a little bit more water, the corner of the state towards Bisbee is grasslands. Okay, as you start going up to the Mogollon Rim, you have chaparral, and then you get up onto the Mogollon Rim, and you have this purple, which is woodlands. Okay, and then, or the blue, which is woodlands, and then the purple is forests, and just tiny bits of tundra. Okay, and so why do we have so many biomes in Arizona? So here's a simpler map of the Arizona landscape that just divides things into a desert region, a mountain region, and a plateau region. And these colors represent why they're different, and that difference is elevation. And as you go to higher elevations, it's like going to a more northerly latitude. So going up is like going large distances in terms of latitude. Great. So if we look at elevation and the high temperature, and then we plot that data from some selected cities in Arizona, what we see is there's a straight line that forms. It's called a correlation. So there's a relationship between temperature and elevation. And I just looked on the Weather Channel, and I got the high temperatures for a particular day in August when I wrote this lab, and you can see it's a straight line going from the highest temperature to the lowest temperature, and so there's a relationship between elevation and temperature. Okay, the same is true of precipitation and elevation. Okay, there's a relationship between precipitation and elevation of cities in Arizona. Okay, how would you describe each relationship? When there's a correlation, when it forms a straight line, it can be positive, negative, or if there's no relationship, we say there's no trend. So if it forms a line and the slope is going up, it's called a positive correlation. And here there's a positive correlation between average global temperature and year going from 1880 to 2000. So over the past 100 years or so, the global temperature is going up. As we get to newer years, the temperature is increasing. Here we have a correlation between two variables, but it's a negative correlation. Okay, the number is going down. And what are we plotting? We're plotting the winning time in the women's freestyle swim in the Olympics. So this is going back to 1930 to 1990. So women are swimming faster, so the winning time is getting lower. So there's a negative correlation over time. And so women are swimming at a lower finishing time. They're swimming faster. Okay, so here's points, and there's no correlation between these variables. What are the two variables? The variables are population, how many people live in a bunch of Western cities, and then what is the average annual precipitation. So here's a city in Arizona. It has a high population but low precipitation. Here's a city in Washington State, and this city has high precipitation and a high population, but then there are a bunch of cities here that they have different amounts of precipitation and lower population. So there's no relationship. People don't all live in the cities with more rainfall, or they don't all live in the drier cities. Okay. All right, go back to those first two slides we looked at. One was looking at elevation of Arizona cities and temperature. Okay, is there a positive or negative correlation? One was looking at elevation of Arizona cities and rainfall. Was there a positive or negative correlation? In the desert biomes, we'll focus on the desert biomes, they'll have less than 10 inches of rainfall a year, or the equivalent in snowfall, so they have low precipitation. The soils are poor in nutrients because moisture prevents organic matter from degrading. And plants adapted to the desert are called xerophytes. We'll look at xerophytic plants in this course. And deserts can be hot or cold. So we live in a hot desert, but if you go north to Nevada and into Utah, that's a Great Basin desert, and they get their snow, their precipitation in the winter is snow. So there can be cold deserts. So here are the 4 deserts of North America. They go north to south, just like the Rocky Mountains go north to south, just like the Great Plains go north to south. In the north is the Great Basin Desert. It's a cold desert, and it covers northern Nevada, Utah, Oregon, part of Idaho. Okay, the Mojave Desert separates the Great Basin and the Sonoran Desert. And if you've ever been to Las Vegas, you've been to the Mojave Desert. The Sonoran Desert is Phoenix and Tucson. It goes into the state of Sonora in Mexico and Rocky Point, and it goes into the Baja of California of Mexico. So deserts don't care whether you're in Mexico or the United States, they'll go right across. The Sonoran Desert has the most abundant plant life and the most abundant animal life of the 4 deserts. 2 reasons. It seldom drops below freezing, and so plants don't have to survive freezing temperatures for long. And the second reason is it gets rain in the summer and winter. So it's still less than 10 inches of rainfall, but we get our summer monsoons and our winter storms coming from the Pacific coast. The Chihuahuan Desert is not as warm because it's at a higher elevation, and it's mostly in Mexico, but it goes into New Mexico, a little bit into Texas as well. Okay, why do deserts form where they do? Okay, so if you remember, the tropical rainforests are mostly at the equator, so 0 degrees latitude. Okay, when hot air rises from the equator, as we go up in the atmosphere, it gets cooler and the rain falls on the equator. So all your tropical rainforests wind up being along the equator. And then as that air comes back down, it comes back down at 30 degrees north and 30 degrees south latitude. So a lot of the world's deserts wind up being at 30 degrees north latitude, like the Sonoran Desert, the Sahara Desert, so on, or Arabia, and 30 degrees south latitude, the deserts of Australia, the deserts of South Africa, and the deserts of South America. Okay, so a lot of it is just due to global air movement. And you can watch this video by David Attenborough, and he will talk about it. So even though earlier we looked at the fact that within Arizona, places with high elevation are cooler and places with higher elevation have more rainfall, overall, even though the Mountain West has high elevation, it has less rainfall than other parts of this country. So what does it say? It says that's a localized effect, but the greater effect is prevailing global patterns, and those prevailing global patterns make the Pacific Northwest very wet. They make the East Coast and the southeastern United States pretty wet, but the Mountain West is quite dry. So if it's quite dry out here, where do we get our water? So a lot of our water comes from the Colorado River Basin. So both Utah and Colorado have rivers draining into the Colorado River. They run into Lake Powell, and then they run into the Hoover Dam near Las Vegas. And from there, the Colorado River goes down into the Gulf of California to Rocky Point. But most of the water has been pulled out by then. And Lake Havasu City is where Lake Havasu is. And if you see on the next slide, there's Lake Mead at Las Vegas. And the Hoover Dam was built in the 1930s. And so the Colorado River water is trapped in Lake Mead. It's currently at its lowest level in history. So we may be needing to reduce our use of water. And as the Colorado River goes down to Lake Havasu, the biggest aqueduct in North America is a 300-mile aqueduct that runs from Lake Havasu through Phoenix and then over to Tucson. It's 336 miles. It was a multi-billion project that started in the 1960s and was finished in the 1980s. And it is the largest user of electricity in the state of Arizona because there are places where we have to pump the water uphill. So where you have to pump the water uphill, it requires electricity. Okay, besides getting water from the Central Arizona Project, we also get water in the Phoenix area from the Salt and Verde River watersheds. So if you go east of Phoenix, there are dams that are holding back that river. And if you've ever tubed along the Salt River, that's release of that water from the Salt and Verde watershed from these man-made lakes. So one of the biggest man-made lakes is the Theodore Roosevelt Dam, which holds back Roosevelt Lake. And then it flows into Canyon Lake, Apache Lake, Saguaro Lake. So from Saguaro Lake into the Salt River, that's where people go tubing. And if you've never done that, it's a fun thing to do in the summertime. Okay, so that's surface water that we've collected from the Salt and Verde watershed. In some parts of the state, there's also underground aquifers. So in the Tucson area, there's an underground aquifer. Unfortunately, if you pump up too much groundwater, it never is able to replenish itself, and that's a story with the groundwater in Tucson. So in the last 70 years or so, we've depleted that aquifer far below what it once was. And so Tucson, like Phoenix, depends on water from the Colorado River. Okay, about 2/3 of Arizona's water goes to agriculture. So there's still a lot of farming in Arizona, although not necessarily in the Phoenix area. And here's an article and a little video if you want to learn more about Arizona agriculture. As Lake Mead goes down, we're going to have to cut back on Arizona water use, and it will likely be a cutback from agriculture rather than urban and suburban use. If you look into it, whenever it comes down to push and shove, you're not going to cut back and tell people that they can't take showers. Instead, you're going to tell farmers that, hey, it doesn't really make sense to grow alfalfa in Arizona. Let's grow alfalfa elsewhere. And you'll see more and more about water use as we go on. All right. Hohokam were the ancestors of the native peoples who live in the area of Maricopa County today. And there's a park in Mesa called Park of the Canals. And they have a remnant of the Hohokam canals. And so people have been farming in the Salt River and using irrigation for hundreds, if not thousands of years. All right, to switch gears a little bit, we're doing a field trip to the Gilbert riparian area. Even though we have less riparian areas, less waterways than a wet environment, because of that, the waterways we do have are very, very, very important. So the riparian area is the surrounding terrestrial area by a stream or a lake. And of course, the biological diversity in this area is much greater than in a desert. There are different kinds of plants and animals. So less than 1% of the total land area in Arizona is riparian area, but it's important because there are fish there, there are amphibians there, there are water source for things like birds. And so here are just some shots of different riparian areas. Here's the Santa Cruz River north of Tucson. This is Fossil Creek, which is near Payson. Oak Creek Canyon's a place a lot of you have probably been. Here's the San Pedro River near Sierra Vista. Here's a river that flows south to north, so it flows from Mexico into the United States. Dry washes in the desert aren't really true rivers, but after a rainfall, the water will run down and run into the wash. So if you go into the desert, you'll see plants like mesquite trees and ironwoods in the washes that you don't see up on the higher parts of the slope. Okay, so if we look at a map of the San Pedro River, let's see, oh, well, let's click that. But if you look at a map, you'll see desert, but then all these trees kind of are snaking along the river. So it's like a little oasis in the desert. It is. So one of the plants we'll see at the Gilbert riparian area are cattails. And as you can imagine, riparian plants are often land plants that have returned to the water, and they have specialized adaptations, things that make them float, ways to pass oxygen to the roots, and so on. The riparian area in Gilbert is a way to attract birds, and a way to attract wildlife, and a way to use the water that has gone through the sewage treatment plant and clean it up for possible reuse. A lot of people go there for birding, and one of the birds we almost always see are egrets. And you can see that aquatic birds are much larger. It tells you they're getting a lot of protein in their diet. They have long legs, they have a long beak, they have a long neck. And so it's pretty interesting to see the adaptations. And so you'll see both desert birds and aquatic birds at the riparian area. You'll see lots and lots of dragonflies. So dragonflies are lots of fun. And one of the reasons why you find them there is they lay their eggs in water. So in an aquatic environment, it's the place to lay their eggs.